All right, we're going to continue the factoring. We're going to factor trinomials. All right, so the first part of this lesson is going to be the simple term where a equals 1. Now this a, b, and c stuff is just referring to a trinomial in standard form with the degree of 2, right? So something that might look like ax squared plus bx plus c, all right? So for example, something like this, what you see here, down here, right? This x squared minus 7x plus 12. This first part is going to be the easy case where a equals 1. So you're going to see that it looks something like this, right? Maybe I could write x squared plus bx plus c, right? You maybe won't see anything in front of it, all right? And that's going to be the first case. So to do this, you maybe remember this from Algebra 1. You're going to find factors of the last term that add up to the middle term, all right? So something like this, x squared minus 7x plus 12, you're going to say what times what equals 12, or what plus what equals negative 7, that sign in the middle, all right? And then in this case, it's going to be negative 4 and negative 3, right? Negative 4 times negative 3 gets me 12, and negative 4 plus negative 3 gets me negative 7. All right, you maybe remember it some other ways, like some people remember like a big X, and they put the product up here, the sum down here, and then they put their numbers here. It doesn't really matter. Or when I taught Algebra 1, I would write the number, and then I would write factors, right? So 12, factors of 12 are 1 and 12, 2 and 6, 3 and 4. Since it multiplies to a positive, adds to a negative, make them all negative. And then this is the one that gets me the negative 7, right? So it doesn't really matter how you do it. I maybe rotate between this and this, right? So one of these two. I typically write it like that. But it doesn't really matter. You remember it how you remember it, right? And then you're going to write your factors like this, x minus 4 and x minus 3. Keep the sign with it. If it was, let's say, positive 4, then it would be a plus 4, right? But it's not, just so you know that that's where the sign comes from, right? It would be x minus 4, x minus 3. All right, so something like this, x squared plus 5x plus 6. You're looking for what multiplies. So what times what gets me 6, and what plus what gets me 5. All right, so 2 times 3 gets you 6. 2 plus 3 gets you 5. So those are going to be two factors. They're both positive. So this is going to be an x plus 2 and x plus 3. All right, simple as that. That's all we got to do. All right, same exact thing with the next one. You're looking for what multiplies to negative 6. The middle term, when you don't see a number, assume it's a 1. So you're looking for what times what gets me negative 6, and what plus what gets me negative 1. In this case, it's going to be negative 3 and positive 2. Right? Negative 3 times 2 gets me negative 6. When you add them, you get negative 1. All right, that 3 is negative, so it's going to be x minus 3. That 2 is positive, so it's going to be x plus 2. All you got to do. All right, we can do the same thing with the next one. You're looking for numbers that multiply to 8 and add to negative 6. What times what gets me 8? What plus what gets me negative 6? In this case, it's going to be negative 4, negative 2. All right, negative 4 times negative 2, negative times negative gets you positive. And when you add the two numbers, you get negative 6. They're both negative, so it's going to be an x minus 4, x minus 2. Sometimes what some people ask, does it matter the order? Can I write it as x minus 2 and x minus 4? That is absolutely fine. It doesn't really matter the order in which you do it. Just be careful with the signs. It's not okay that you say that this is, I don't know, plus plus, for example, right? Because those don't add to the middle term, right? So that's not okay, but switching the order of them is fine. I can say x minus 2, x minus 4. That's perfectly fine. So more examples. Something like this. I'm looking for numbers that multiply to negative 24, add to negative 5. Right, so negative 24 adds to negative 5. I think this one's going to be negative 8 and a positive 3. Right, when I add these together, I get a negative 5. All right, so it's going to be an x minus 8 and x plus 3. That's all we got to do. All right. With the next one, you're looking for numbers that multiply to 1 and add to 1. right? The only factors of 1, if I had to pick 2 of them, are going to be 1 times 1, right? Those are the only integer factors, or -1 times -1. But then as you can see, none of these are going to add to 1. So really there's nothing that we can do to this. I'm going to say that this is not factorable. Right? There are no two numbers that when you multiply you get 1, and that you add the same two numbers and you get a positive 1. Right? If I did -1 and -1, that would get me a -2. If I did 1 and 1, that would get me a positive 2. Neither one of those add to that middle term, so we can't factor this. So we leave it alone like that. That's perfectly fine to say if it's not factorable. All right, so when you look at the next one, we're looking for numbers that multiply to -18, add to -3. All right, this one's going to be a -6 and a positive 3, right? When I add those, I get a -3. And you see that I'm writing it differently than I did in the previous slide, right? The thought process, right? This part doesn't matter. I don't really care about this. Some people are able to just write it once without having to show their thought process behind it. That's also perfectly fine. After a certain point, I'll expect that you guys know how to do it, and maybe you won't have to write as much down, right? But because you guys are kind of getting a little bit of a refresher, right? Maybe you haven't done this since Algebra 1. I'm writing out what the thought process might be like on the side. But again, this part, the thought process doesn't really matter. I don't really care how you do it as long as you get the right factors. All right, same thing over here. What multiplies to to 2 and adds to 3? It's just going to be 2 and 1, right? If I add those together, I get a positive 3. So this is going to be an x plus 2 and an x plus 1. All you got to do. All right. So now we get to the case where a does not equal 1, meaning you're going to see something that looks like this: ax squared plus bx plus c. You're actually going to see a number there, and it's not just going to be an x squared. All right. The first option says use trial and error. I would never use trial and error, especially when you're taking a test or a quiz. You can maybe try to guess some factors. I really wouldn't recommend that though. I'll show you the method that I would use instead, and then the next slide shows you another method, another valid method. So I'll show you what I like first. All right, so I call it, some people call it different things. I call it slide and divide. All right, so the process between this one and the one in the next slide starts off exactly the same, right? So we're going to multiply the first and the last this time. So before it was factors of the last that add to the middle. Now it's the factors of the first times the last. If I do 2 times -15, that gets me a -30. So now I'm looking for factors of -30 that add to my middle term 1, right? And that's going to be a -5 and a positive 6. Once I have those factors, I can still write it like x minus 5 and x plus 6. But keep in mind, I had a number in front of my x squared. I'm going to divide both of these numbers by that number in front. If it simplifies, you would simplify it, right? So something like 6 divided by 2 on this side, that becomes 3. So this factor is going to become an x plus 3. Right? 5 over 2 does not simplify, so I'm going to take the number at the bottom and slide it out front. Right? Slide and divide. All right? And then those are your factors. Right? Simple as that. Now I'll show you an equally valid method is by factoring up by grouping. Right? So when you have a trinomial like this, I'm going to use the exact same one. You can multiply the first and the last just like before. So I can do 2 times -15, right? -30, factors of -30 that add to positive 1, -5 and 6, right? That step stays exactly the same. But what you do instead is you can split up that middle term. So 1x is the same as saying -5x plus 6x, right? Hopefully you guys agree, right? -5x plus 6x, when you add them together, you do get 1x. And then I would bring everything else down with it. So I would bring the 2x squared, and I would bring down the minus 15. And then now I have 4 terms. When you have 4 terms, you can factor by grouping. Group the first two, group the second two. The common factor of the first group is going to be an x, and then it's going to be a 2x minus 5. Greatest common factor of the second group looks like it's going to be a positive 3, and you're also left with a 2x minus 5. All right? That 2x minus 5 matches, so I get a 2x minus 5 on the outside, and then the x and the positive 3 are left over, and those are going to be in their own set of factors. So you can see we get the exact same answer. It's a preference for you. There's not really one method that works better than the other. It's really just personal preference. They work exactly the same. You will get the exact same answer, assuming you follow the correct steps. Right? Some people maybe get this far and they get those two numbers and just leave it like this. Right? And they maybe forget to either divide the two, or they forget to split up the middle term and factor it by grouping, right? But this by itself is not correct. You have to either divide the two or you split it up like we did here. All right, so let's try it with some examples. Something like number 8. Again, there's a number in front of our x squared, so I'm going to multiply. First times the last, 2 times 3 is 6. So I'm looking for factors of 6 that add to negative 5, and that's going to be a negative 2 and a negative 3. All right, that gets me negative 5. So you can do it both ways. I'll show you both ways for the first one, and then I'm going to stick to one method. All right, so I'll do slide and divide first. So it's going to be x minus 2, x minus 3. Keep in mind there's a 2 in front, so I'm going to divide everything by 2. If it divides, you would divide it, right? So 2 over 2 here, that becomes a 1. And then 3 over 2, that can't simplify. I'm going to slide the 2 out front. All right, so we get something like that. All right, and I'll show you the grouping way also, right? So again, they both start out exactly the same. I would still need to find that negative 2 and that negative 3. But you would split up the middle term. So it would be 2x squared. Instead of negative 5x, it would be minus 2x minus 3x. Right? That negative 5 we split into negative 2 and negative 3. And then bring everything else down. Right? So that plus 3 as well. And then you can group the first two. Group the second two. GCF of the first group is going to be a 2x. And you're left with an x minus 1. GCF of the next group is going to be a negative 3. And so you're left with an x minus 1 as well. Those factors match, and so we get x minus 1, 2x minus 3. All right, see that we get the exact same answer. So it does not matter how you do it, that is a choice for you. All right, so let's do the exact same thing in this next one. I'm going to stick to slide and divide. So this method right here, some people find that a lot faster. It is a little bit faster. But if you're comfortable doing it by grouping, because we learned that in the previous lesson, then do it that way. It does not matter. So I'm going to do 2 times negative 27. That gets me a negative 54. All right, and then I need factors of negative 54 that add to negative 3. And that's going to get me a negative 9 and a positive 6, right? When I combine those, I do get a negative 3. So I'm going to do x minus 9, x plus 6. I have a 2 in front. I'm going to divide them both by 2. If it doesn't simplify, so 9 over 2 does not simplify, slide the 2 in front. 6 over 2 does simplify. That would become a 3. All right, so x plus 3. And that's all we got to do. If you did it by grouping, you would have gotten the exact same answer. All right, 2 more examples. The only way that these can get harder is if the numbers are bigger to work with. All right, so something like this one, 8x squared plus 51x plus 18. We're going to do first times the last. You can do it off to the side if you need to. If you do 18 times 8, you should get 144. So I need factors of 144 that add to 51. Right, so try to think about it. I mean, we see a big number like this, and some people like to give up and maybe take a shot in the dark and say that it's not factorable or something like that. I don't know. I've seen some crazy stuff. But you do want to try and check and make sure that it actually doesn't have any factors. that add to the middle term, right? Because sometimes it does, and maybe you just haven't thought of all the factors. The most common factors that people think of are 12 and 12. If I add those together, I get 24, right? So that's nowhere near 51. So let's think of something else. Let's think of maybe factors that are farther apart, right? So maybe the farthest one that I can think of is maybe like 2 and 72, right? If you didn't know that, you could do long division off to the side. 2 times 72 does get you 144. When I add them, I get 74. Okay, now I'm too high up. I want to get to 51, right? And another set of factors, maybe 2 didn't work, but maybe 3 does. If you weren't sure, you would have done long division off to the side. I've seen a lot of you do this on your quizzes and tests. That's perfectly fine. I would rather you do this than try to guess and get it wrong. And if you do this, you will get that 3 goes into 144 48 times, and that's exactly what we wanted, right? 3 plus 48 does get you 51. So I'm going to do the exact same method as before. It's going to be an x plus 3, x plus 48, all right? There's an 8 in front, so I'm going to divide them both by 8. 3 over 8 doesn't simplify. I'm going to slide the 8 out front. This is going to be an 8x plus 3. 48 divided by 8 does simplify. I get 6. So this is going to be an x plus 6. All right, so we get that as our final answer. All right, last one. The only other case where it might get a little bit trickier is if there's a negative in front. What I like to do is I like to take the negative out from the beginning. So this becomes a negative, and then once you divide everything by a negative, it just changes the sign of everything on the inside. So I get negative, and then in parentheses 6x squared minus 17x minus 3. I would do this every single time, just because if you don't and you do it, no matter what method you do it, might get confused by seeing all those negatives. You're going to want to take out a negative by the end of it. All right, so let's just get into the habit. Let's just start taking out the negatives from the front, from the very beginning. All right, and then once we do that, let's do the same process as before. We're going to do 6 times negative 3, so negative 18. Factors of negative 18 that add to negative 17 are going to be negative 18 and positive 1. All right, so I'm going to do the exact same method as before. I'm going to do an x minus 18, x plus 1, divide them both by 6. 1 divided by 6 doesn't simplify. I'm going to slide it out front. 18 divided by 6 does simplify. That's going to get me 3. Divide it, we get a 3. And then don't forget about the negative out front in our final answer. So I get negative, and then in parentheses x minus 3, and then 6x plus 1. All right, so factoring trinomials, hopefully not too bad. This is typically what people find most familiar. All right, and then that covers all of the major factoring topics, and in the next lesson, we're going to factor completely.